Continuing. Critical points. Right, 17 questions, and this is material which I've glazed over, and so it's exactly what I should be doing. Right, now, first we find f prime of x. That would be 24x squared plus 162x minus 42. Then we think about what when it's equal to 0. And well, we should half everything, but even better than that, divide everything by 6. That would be good. Yes, that would be good. All right, and then we would obtain 4x squared plus 27x minus 7 equals 0. And then we try and find the zeros of this by factoring. So I think this is the answer. So I think it's a quarter or minus 7, right? But now, what is the definition of a critical point? It's where f of c is where let c stand for the value of a critical point in the domain of the function. Then a critical point is defined as a point such that f of c exists and f prime of c is either 0 or does not exist. Clearly, it's these two, because a polynomial is defined over the whole of the reals, that's in the domain, and it's differentiable everywhere. That's what I think the answer is. Right, so the next 5 appear to all be polynomials, including, well, 6 actually is as well, but first we'll just see if we got this right. Okay, that's good. Recall that critical points are simply where the derivative is 0 and or doesn't exist. Okay, good. Now, question 2, determine the critical points of r of t equals 1 plus a to t cubed plus 5t to the 4, take 2t to the 5. So we find r prime of t, the constant disappears, this becomes 240t squared, this becomes 20t cubed, this becomes negative 10t to the 4. We write in descending powers of t and equate to 0, but then we also multiply everything by -1. At the exact same time as well, divide everything by 10. So it would be t to the 4 minus 2t cubed plus 24t squared equals 0. Then we factor out t squared and we try to factor the implied, the quadratic that would be in the brackets, in the larger brackets here. So what would that be? I think it's 6 and 4. So t minus 6 and t plus 4. Uh-oh, but wait. That's positive, isn't it? So, and again we see an arithmetic error. Again. Just keep on happening. Can't seem to stop myself from making these blimmin' arithmetic errors. Okay. 0. So t equals 0, -4, or 6. And just a second here. I'll need this. And okay, first I'll put that on there. I'll do this. This will help. It'll shield my room from this restraining heat. Keeps on being blasted out. Okay, anything else? Just a sec. Open the window a little bit more. Okay. So I think that's the answer. And that's correct. That's great. Next up, determine the critical points of g of w, where g of w equals 2w cubed, take 7w squared, take 3w, take 2. Okay, so first we find g prime of w, which is 6w squared, take 14w, take 3. Then we see that we have a quadratic here, and it's not clear if it can be factored. So applying the discriminant, b squared minus 4ac, so that squared minus 4 times that. That squared is 196. That squared is 24 times 3, which is 72. Adding these together, we get 268. So that actually can't be factored, I believe. 24 times 3 is 72. 14 squared is 196. Add them together, we get 268. So yes, I believe it cannot be factored. So 268 is 134 times 2, 67 times 4. All right. So we can, so QF W equals 14 plus or minus root 268 all over 12, which is 14 plus or minus, that's 134. Then that turns into 67. So we get 7, 7 and 6 there. So I believe those are the roots. Now we'll see. All right, excellent. That's correct. Problem 4. Okay. Determine the critical points of g of x where g of x equals x to the 6 minus 2x to the 5 plus 8x to the 4. So g prime of x equals 6x to the 5 minus 10x to the 4 plus 32x cubed. Now solving, bringing it down here, I'm going to do factor out x squared and divide by 2 all in one step. Factor out x cubed rather. So x cubed all times 3x squared minus 5x plus 16 is equal to 0. It's not evident to me that that can be factored, so I have to apply the discriminant, or determine the discriminant rather, which is b squared minus 4ac. So minus 5 squared minus 4 times 3 times 16. And let's see, have I made an arithmetic error again? No, that seems to be fine. Okay. So we get 25 there, and then minus 12 times 16. And 12 times 16 is 192, so 25 minus 192. Which is minus 167. All right. Okay, good. Okay, next up, determine the critical points of h of z, where h of z equals 4z cubed, take 3z squared plus 9z plus 12. Okay, so first calculating h prime of z, that would be 12z squared minus 6z plus 9. And then finding the zeros of this, we factor out 3. Four z squared minus 2z plus 3 is equal to 0. And even though it's four minus 48 which is minus 44. So so there are no critical points. All right. Here in problem 6. I'm actually kind of curious, when does this notification go away? Really? Never? All right. Okay, sort of calculates it from the beginning. Anyway, determine the critical points of Q of x, where Q of x equals 2 take 8x all to the 4 times 8x squared take 9 all cubed. All right, so first we must differentiate. To do that, we notice that we have so we'll apply the product rule. So what will come in the front? 4, and then that will be multiplied by negative 8. And that's it. 4 times negative 8 is negative 32. So that'll be there. And that will turn into a 3. And that will stay just as it is. And then we'll have a plus symbol. And when we differentiate the second function, 3 will come into the front. But 3 times 2x actually, which is 6x. That's what will come into the front. And what will happen to this? Well, that will turn into a 2. So if I did that right, then we have to determine where that's 0, which looks like an absolute nightmare until I notice that I have copies of this and copies of this. So what I'm going to do is do q prime of x equal, first I'm going to factor out 2 minus 8x, and I'll factor that out 3 times. Then I'm going to factor out x squared minus 9 twice. And now, in a big pair of brackets here, I'm going to write minus 32, and I'll do 1 copy of that, just like that. And then I'll write plus 6x, and then I'll do 1 copy of that, just there like that. And it'll be like that. And then I've got to clean up what's inside the bracket. So that times that is negative 48x squared. And that's negative 32. So I'm going to have negative 80x squared just there like that. And then I have 12x. And then I have 288. So it still seems like a total nightmare. You know? But all right. At this point, we have a quadratic right there. So I'm going to do the discriminant here. So I'm going to square. I'm going to square 12. I'm going to take away 4 times negative 80 times 288. And do that now. So 144 plus 4 times 80 times 288. And I get that. And that is not a square number. Okay, so, but it is positive. And we've got 92,304. It's minus 2 over minus 8. Well, a quarter. And then this thing right here. All right. Okay, so he ends up with a totally different. Is it totally different? It's not that different. Actually, seems okay. So that. Yeah. So he gets the same answers that I do. That's great. Not half bad. Not even a quarter bad. Next up, problem 7 and 8. Okay, it goes on for some time, but that's absolutely fine. Whoa, whoa, whoa. Okay. Right, so we've got to determine the critical points of f of z here. So first we think about what is excluded from the domain of f. So b squared is just going to be 1, and then minus 4 times a times c. Well, that'll be negative. So no roots. So that will never be 0. Now f prime of z. Well, this is the quotient rule. F prime g minus f g prime all over g squared. F prime g, so that's just 1. That's times that. Minus f times g prime 4z plus 1 and the square of that. Now, sorting that out, I'm going to make a bit more room here. We've got 2z squared minus 4z squared, so that would be minus 2z squared. Then we have minus 17z from a single z, so minus 16z. And then 8 minus 4, well, that would just be 4 by itself. And then our job is to find out where that is equal to 0. And that's going to be equal to 0 when the numerator is equal to 0. So I could just set that equal to 0, which is exactly the same as halving everything and changing the signs. So z squared plus 8z plus 2 is equal to 0. Oh, minus 2, beg your pardon. And does this have roots? Does it have roots? Well, apply b squared minus 4ac. And when you do that, you'll get 8 squared minus 4 times 1 times minus 2. And that's equal to 72. So it does have roots. But, you know, they're not the best. So z is equal to minus 8 plus or minus root 72 all over 2. Root 72, well, that's root 9. Oh, no, it's just 36. So it's minus 8 plus or minus 6 root 2 all over 2, which is minus 4 plus or minus 3 root 2. And there you go. So yes, so we found f. First of all, it's all of the real numbers are totally fine to go inside here because this is always positive. Second, once we found f prime of z, we then need to find out if where it doesn't exist. But again, that will always be positive there. And so we just need to find out then where it's equal to 0. And I believe that it's 0 for these values here. So I think those are the two critical points. Now we'll see if that's true. Awesome. Brilliant. Tremendous. Problem 8. Determine the critical points of r of x, where r of x is 1 minus x all over x squared at 2x take 15. Okay. So we need to find r first. F prime g minus f g prime. So f prime minus sign f g prime. So that's going to be 2x at 2. And then all of that will be divided by the square of that. And because I'm squaring it... No, wait. Sorry, that logic doesn't work. I was thought for a moment, because I square it, I don't have to worry about it, but no, that is sorely mistaken. All right, so clean up the numerator. Okay, so to not run the risk of making mistakes, I'm just going to do this. And let's see, I'm going to multiply that out. So what I will get is 2x plus 2 minus 2x squared minus 2x. And that amounts to minus 2x squared. Those will cancel out, and then I get a plus 2. And then these signs flip, so that turns into plus 2x squared minus 2x minus 2. Just like that. And then I get this. So I think I've taken the numerator as far as it will go. And the important thing for me to do now is to find out when that's equal to 0 and when it doesn't exist. Now, it doesn't exist for -5 and 3, which is exactly the same as for when r of x doesn't exist, and so we can actually abandon those. And when is it equal to 0? Well, it's equal to 0 when the numerator is equal to 0. So solve. So it has no critical points, I believe. Could be wrong. Brilliant. It says do not get excited about that, but I actually am extremely. Determine the critical points of r of y, where r of y equals the fifth root of all of y squared take 6y. Okay, so no, the fifth root is defined on all real numbers, sorry. Oh. Okay, so we're going to go straight into finding r prime of y. One-fifth of y squared minus 6y. And that's to the negative 4/5. And that had all been multiplied by 2y minus 6. If I want it in the most aesthetic form, just for my own sake, I would put 2y minus 3 there on the top. Cool. I like that. Anyway, all right, so now that we've differentiated it, we want to determine where it's equal to, where it doesn't exist. Right, that's my first thing to say. My next thing to say is that when the whole thing, when r prime of y is equal to 0, okay, well, that would be at 3. I think it's 0, 3, and 6. Hooray! Well, not actually that bad. Determine the critical points of h of t, where h of t is equal to 15 minus brackets 3 minus t, close brackets, all times that quadratic there to the 1/3. All right, so All right, so it all seems fine there. So fine, we're just going to go straight ahead and compute h prime of t. Okay, the constant would disappear, and we have a product. So minus sign, big brackets, and you better roll up your sleeves because this is going to be a big one. Okay, derivative of the first function, well, that would just be minus. And leave the second function alone. Squared. Take 8t plus 7 to the 1/3. Okay, and then a plus sign. Leave the first function alone and do the derivative of the second function. Okay, so I'm going to get a third coming to the front, and then the function itself to the minus 2/3, and then the derivative of the function, which is 2t minus 8. Which is not very pretty. It just isn't. And I'm supposed to what? Either find out where that doesn't exist, or find out where that is equal to 0. And I am out of my depth if that's what they're asking for. Okay, so all right. So they am I at least on the right track? All right, bit of messy algebra here, but let's see if we can do it. Wait. It's down there. And all of that is being raised to the 1/3. And so what do you have to divide that by? right? Yeah. That will go on top. Unfortunately, I mean, I remember all numbers here, so and anyway, the third shouldn't be on the top. Goodness me. Should be down here, shouldn't it? Of course, that makes sense. Of course, you'd have to multiply that like that for them to have the common denominator. Yes. All right. Okay, so minus 2t squared. That's plus 2t squared. So 5t squared. 6t plus 8t is 14t. So minus 14t. So minus 24 minus 14 is minus 38t. And then you have 21 and 24, which makes 45. Okay. Now that we've found h prime of t, what we need to do is we need to find out where this is either undefined or 0. That would have to be t minus 7 times t minus 1. T is equal to 1 or 7. And then it's 0 when this quadratic is 0. So So that's 544. Which is not a square. No, it's 4 root 34. All right. But that has to exist for the original function, don't they? They all have to actually work out for the original function. So we'll wait for them. Okay, good. He agrees with me. Excellent. Problem 11. Determine the critical points of S of z, where S of z is equal to 4 cosine of z, all minus z. Sometimes I say z, sometimes I say z, just to keep myself on my toes. So S prime of z. Sine differentiates to, cosine differentiates to minus sine. So minus 4 sine z. Negative 0.252. Right, okay. So I'm curious. If we have a problem for which the answer is all solutions to arcsine -1/4, which in all fields of science Right, we'll ask the three in the modern day and age. Apparently they're oracles. No. The reason why I ask the LLMs is because they are purpose built to give back typical answers. If you want original creative research, they struggle with that for various reasons. But when it comes to typical answers, I mean, it's pretty much like what they're built for. Okay, so. All right, so. Yes, it was a typo. All right, so I get this now. Anyway, let's move on. Problem 12. F of y equals sine of y over 3, all plus 2y over 9. We have to find the critical points. So we'll just immediately get to computing f prime of y. All right, so we'll go with that convention now. Oh man, that's really the result of my calculator. Okay. All right, so that's arc cosine of negative 2/3. All right. So now 2 pi minus that answer minus pi. I don't get it. What? Oh, right. Oh, goodness me. Okay. I get that. I get that. Mm-hmm. Oh, so the other answer would actually be 1.5 pi minus Whoa, did I forget to, oh yes I did. There we go. Oh, and then I forgot to do this last step here. Times everything by 3. Hold on now. Yeah. So we're in total agreement, except I just, for some reason, didn't see that. Not sure why. Six pi n. $13. 13th problem. Find the critical points of v of t, where v of t is equal to sine squared of 3t plus 1. Hold on. First, differentiate. Three cosine of 3t. Okay, that's exactly the same as solving that, of course. And wait. We don't need that. We don't need that. All right. Oh no, when it's 0, that's precisely the one without. Yeah. This is wrong. Why aren't you getting this right? Zero pi, 2 pi, 0 pi, 2 pi, 3 pi. 0 pi, 2 pi, 3 pi, 4 pi. Okay, so 0 plus pi n. Right. Pi over 2, of course. That was it. But it's not 2 pi n. Well, for the sine one, but you don't split it up into two families. You don't need to. Do you? But why would you need? But you don't need to, though, do you? Yeah, a third. So it goes a third, 1, 1 and 2/3, 2 and a third, like that, and then it goes 2/3. Anyway, right, for the last 4 here, I'm just going to take a bathroom break, and then I'll be right back. Now, problem 14. F of x equals 5x all times e to the 9 minus 2x, and we've got to find the critical points of this. So it's product. So, product rule. First, just noting where. No, it's defined on all values. Okay, that's fine. Okay, so 5 u to the 9 minus 2x plus that'd be minus 10. I think that's really it, but I could be completely wrong about that. Mm-hmm. Fifteenth problem. Find the critical points of g of w where g of w is equal to e to the w cubed, take 2w squared, take 7w. So we must find g prime of w. And this is a chain. Wait. All right, got it. Determine the critical points of r of x where r of x is equal to the natural logarithm of x squared at 4x at 14. Finding r prime of x. The derivative of the derivative of ln of f of x is f prime of x over f of x, is it not? No. Right, let's get my thoughts in order. First, that's simply true. Oh, that should be that. Hmm. Got it. Right, I've got to take a small break and be well, be well.